interesting moment. We are looking at numerical integration, and it is the last topic for Math 209. That's a beautiful one. Numerical integration. So what did we say about numerical integration? We said it is used to obtain approximate answer of definite integrals, right? That cannot be solved analytically. And so it is a process of finding the numerical value of a definite integral. Very interesting to say. Very interesting to say. And we said when this technique is applied on a function of simple variable, we said the process is called the quadrature. Now, it is very important for us to know that one of the ways of solving numerical integration is the use of trapezoidal rule. The use of trapezoidal rule. And this is the formula that we have. We have I is equal to the boundary integral from a to b f of x dx is equal to h over 2 open brackets y naught plus yn plus this. Is that okay? All right, so without wasting much of your time, we'll be going quickly to the calculations. We will be going quickly to the calculations. So we want to say example. We want to cite an example. Example 1. We said calculate. You might want to write that down quickly. We're asked to calculate the value of the boundary integral from 0 to 1 of 1 over 1 plus x dx. You have to correct, all right, correct to 3 decimal places, 3 decimal places, or 3 significant, 3 significant figures, 3 significant figures. You are taking 6 intervals. We are taking what? 6 intervals by the trapezoidal rule. By the trapezoidal rule. See that? By the trapezoidal rule. All right. So this is a very interesting question. How do we get to it? How do we solve this problem? Is that okay? So to solve this problem, we must be aware that we need to write our parameters. So let's go. Steps. Let's solve this question together. Solution. All right. So step 1, we identify our f of x, comma. We identify our a, comma. We identify our b, comma. We also identify our n, comma. All right, and we identify our h. Okay, so from the question, you can remember I said in the trapezoidal rule, we said that so let's compare. So, okay, by comparing. So let's compare. I is equal to boundary integral from a to b of f of x dx, right? From this particular statement, right? So let's compare this to the question we have. The question says boundary integral from 0 to 1 of 1 over, if you are confused, this is what I'm talking about, right? So let's compare it to that. Let's compare it to boundary integral from 0 to 1 of what? Of 1 over 1 plus x dx, right? 1 over 1 plus x dx. So by analysis and by common sense, we now know that it means that our f of x in this case, now look at our f of x, is this person, right? Our f of x is 1 over 1 plus x. I believe you understand now. We are comparing them, right? Comma. Our a, see, This is A here, this is A here, so A is 0. We are comparing them. Our B is this is B here, B is 1. We are comparing them. Now our N is 6, because the question says calculate the value of this correct to 3 significant figures taking 6 intervals. So regularly our N is the number of intervals, right? Note that, let's note it there. Our N is the number of intervals. Our N is the number of intervals. Our N is the number, so our N in this case is 6. Did you see that? So H, as it were, H, which is the interval of differencing, the formula is, also know that H is always B minus A over N. Let's not forget this, B minus A. So H here in this case, what is B now? B is 1 minus, what is A? 0 divided by 6. Alright, because we have stated the formula for H here, right? Is that okay? So our H, by method of common sense, is 1 over 6. Did you see that? That's step 1. Step 1 is that we identify our f of x, we identify our A, our B, our N, our H by comparing, right? So let's compare. So step 2, what is step 2? Our step 2 is to figure out our table. So let's figure out our table. So let's construct a table quickly. So let's construct our table quickly. All right, beautiful. So here we're going to have x, here we're going to have y equals to f of x. All right, so we are saying from 0 to 1. Don't forget the boundary integral says that. From 0 to 1. So we are taking the chances from 0 to 1. Whatever the boundary integral says is what we are going to do. We are taking the chances from where? From 0 to 1. All right, but our interval of differences is 1 over 6, 1 over 6, 1 over 6, 1 over 6. All right, so let's do that quickly. From 0 to 1. So now let's calculate. This should be 0. We're starting from 0. So what is 0 plus 1 over 6? 0 plus 1 over 6 is 1 over 6. What is 1 over 6 plus 1 over 6? I believe that's 2 over 6. What is 2 over 6 plus 1 over 6? I believe that's 3 over 6. What is 3 over 6 plus 1 over 6? I believe that's 4 over 6. What is 4 over 6 plus 1 over 6? I believe that's 5 over 6. What is 5 over 6 plus 1 over 6? I believe that's what? That's 6 over 6, which is approximately 1. Have you now seen that we have come from 0 and we have ended at 1, what the boundary integral says? Did you see that? So anytime you see an integral, for example, of 0 to 5, and there is an interval of difference, you keep following that h. The h you are seeing in this question, this particular h, is the interval of differences. So you start from that 0, you start adding the h, 0 plus this, whatever it is, you put it in the next bracket, if 1 over 6, you add again, you put it in the next bracket, you add again. So I'm just trying to cite an example. Is that okay? In some cases now, for example, this h now can be 2 over 6. So what you'll be doing is, if you have an integral of 0 to 7, you will now say 0 plus 2 over 6, whatever your answer is will be here. You write it there, 2 over 6 plus 2 over 6, you have 4 over 6. You keep doing it until you get to 7. Do you understand? So that is what we mean there. That is what we mean in that particular space. So we figure out our table, and our table is what? 0 to what? 1, because the integral says 0 to 1. And so if the integral says 0 to 1, the question, look at the question, from 0 to 1. And so the integral says 0 to 1. We need to start finding out what our interval. I told you in Maths 209, H means interval of differencing. Interval of differencing. H is asking you, it says, sir, what differences should I take? So the differencing is, you're going to get that formula from here, you know, where we said H is equal to B minus A over N. That's okay. That's a good one. All right, so Y is equal to F of X. So what do we mean? You know, F of X from the question, we have F of X as 1 over 1 plus X. 1 over 1 plus X. So we are saying when X is 0, F of X will be 1 over 1 plus 0. Do you understand me now? So that's how to figure out our table. So that will be 1 divided by 1. That will be, okay, F of X is 1 over 1 plus X. So when X is 0, so this will be 1, right? F of X is equal to 1 over 1 plus X when X is 0. So we are just slotting in that value. Is that okay? All right, so just as we said F of X would then be 1 over 1 plus X, and then you start to impute the value. So we said when X is equal to 0, F of X is 1 over 1 plus 0. So we have 1 over 1, which is 1. So we're going to put that here, 1. Is that okay? The next one is when X is 1 over 6. So our answer is 0.857. 0.857. When X is 2 over 6, our answer is 0.75. When X is 3 over 6, our answer is 0.667. When X is 4 over 6, our answer is 0.6. When X is 5 over 6, our answer is 0.545. 0.545. You can also check that in your calculator. When X is 6, that's 6 over 6, which is 1, our answer is 0.5. 0.5. So you figure out your table. Now step 3 is to use the trapezoidal rule. Step 3 is to use the trapezoidal rule. Is that okay? You use the trapezoidal. No. You have I is equal to H over 2 into the bracket of Y naught plus Yn into the bracket of 2 into the bracket of now let's go back to where we use the formula. The formula says that what? Y1 plus Y2 plus Y3 as we approach Yn minus 1. Okay? Y1 plus Y2 plus Y3 as we approach Yn minus 1. So in this case, H is equal to, that's H is, what's our H? Let's go back to the question. Our H in this question is 1 over 6. 1 over 6. So we have 1 over 6 divided by 2 into the bracket of Y naught. What is the beginning of the table? Y naught. So this is Y naught, please. This is Y naught. This is Y1. This is Y2. For the sake of it, this is Y3. This is Y4. This is Y5. And this is Y6. So Y naught is 1. Y naught is 1. Yn, the end of the table is 0.5. You see that? 0.5 plus 2 into bracket. Y1 is 0. You start slotting the values, right? You start slotting the values. 0.857. 0.857 plus Y2. What is Y2? 0.75. 0.75 plus, what is Y3? Now this n here, yn means the ending of the table. Y naught and y is just like me saying the beginning and the end. So y naught is 1 because this is it here, 1. And yn is the ending of the table, which appears to be y6. Do you understand? 0.5, the beginning and the end, right? So this is 0.857, this is 0.75, y3 is 0.667, 0.667. You know, this as we approach 667. Then y4 is 0.6 plus 0.6. Then y5 is 0.545 plus 0.545. Is that okay? We have it as this. So your I is 1 over 12. Is that not? When you have 1 over 6 divided by 2, that's 1 over 6 times 2. You know, that's 1 over 2. It's just like you say 1 over 6 times 1 over 2. That's 1 over 12, right? All right. So we have it as this. So this is so let's put this in the calculator settings. Let's calculate these values all together. And so when we do this, we then begin to calculate the values of this. You know, you are no longer children. You should be able to solve this. When you add up this value, you multiply it by 2. When you multiply it by 2, I believe you're going to have 6.838, right? And then you add these two up. When you add them up, you're going to have 8.338, and then you divide by 12. You divide by 12. That's going to give you 0.694. Now, if you want to truly know the answer to this without solving, right? You just quickly want to know without using the trapezoidal rule. You just want to know the answer to this 0.1 1 over 1 plus x dx. You can easily calculate that from your calculator, right? Did you see that? It's going to give you 0.693. 0.693. That's to tell you that what? You are on the right track. Is that okay? But here, using the trapezoidal rule, we got 0.694. 0.694. And this is a beautiful thing that you have learned the trapezoidal rule. By what? Trapezoidal rule. By the trapezoidal rule. Alright, so we want to look at something very interesting. We want to look at the Simpsons 1/3 rule. The Simpsons 1/3 rule. Is that okay? The Simpsons 1/3 rule. All right. The formula says that when you have that, you have